Welcome, week 7, our History GCSE Revision, and we're still looking at medicine. And thanks for everyone who's doing all the questions. I really appreciate that. So let's do this. Let's move on. So we're still on section B, which is the 1250 to the present day, and we're going to finish the last section of today. And the question we're going to do is the explain why question, the 12 marker. And if you want to do this for homework, that would be amazing. So, why was there rapid change in the treatment of diseases from 1900 to the present day? So, they will, as I keep saying, they're going to give you two things. In this case, it's going to be the NHS and antibiotics. But again, in order for you to get the highest mark, you've got to include something else there. Right. So, usual format. What did they think caused disease? How has treatment improved? And our depressing case study this week is about lung cancer. So this is a big slide, but it's actually quite easy to understand. So the most important, well, one of the biggest developments at this time was our understanding of DNA. So this was begun by this guy called Mendel, and he kind of made the connection, like we all do, where people say like, oh God, you look like your mum, don't you? And you're like, no, I don't. And really, you know that you do. So Mendel made the connection that human characteristics are passed down in generations. So sometimes you may look at photos of your grandparents and you'll be shocked and surprised at how similar you look to them. So this was also helped by electron microscopes. It's really increased the magnification. So scientists could analyze cells and they realized that every cell contained DNA. This was developed further by James Watson and Robert Crick at Cambridge University, and they kind of worked out how the DNA codes fitted together. So the ACGT code, I think, from memory, they kind of fitted that all together. And with the help of Rosalind Franklin and Maurice Wilkins, who were doing some interesting photography work on DNA, they realized that DNA fitted together in what was called a double helix structure. So, why is this important? It's all very scientific and, a little bit nerdy. What's it got to do with medicine? Well, in 1990, the Human Genome Project began, and scientists around the world began to map and identify the millions and millions of human genes. So why is that important? I think, it's important for a number of reasons. Initially, we're really at the beginning stage here. Doctors are using this to test for genetic conditions. The most famous example is, Down syndrome for pregnant women. Also, they can test for high risks of cancer. So if someone in your family's had cancer, they may do tests on you to see what the likelihood is. So, for example, Angelina Jolie had her breast removed because they did testing and she'd had it within her family. Also, stem cells. So, stem cells are basically cells that can be produced, or my understanding of this is like healthy cells regrown. But the problem is, we're at a very early stage of the DNA. There's no currently any treatment. There's no DNA treatment. There's no prevention. So, but this is something in your lifetime that will develop. Something that is just so obvious to us, but 20, when I was your age, wasn't really anybody didn't really think about it. Is the impact of our lifestyles on our health. So I don't even have to say this. Smoking kills. Drinking too much alcohol is not very good for you. And obviously, sugary diet, sort of, burger diet, it's not going to be good for you, and obesity and all that. So I know that's obvious to us, but even, when I was your age, there wasn't the evidence, the proof that smoking, it's fine, it's good fun. That's what people used to think. So, now we have the evidence. There's been a concerted effort to try and reduce these lifestyle factors. We live in a technological world. This has been a massive impact in medicine. So you've all had your blood sent off for tests, I'm sure. The use of x-rays, scans, things called endoscopes that look down your throat, like on the picture there, hugely has increased doctors' ability to see inside the body. Probably some of you wear like trackers, like wrist trackers. This is now commonplace and accepted. So people with slight heart conditions, they can monitor the beat over a period of time. In terms of practical improvements, things like prosthetic limbs, so people who've been injured in wars, or a lot of elderly people these days will have a pacemaker to kind of regulate the heart, and diabetics will use insulin pumps to make sure they get the right dosage of to enable them to to survive. So this is quite an important slide, and quite a complicated slide. So this is really about the use of chemicals to destroy bacteria. And this become known as the magic bullet. The first magic bullet was developed by Ehrlich and his Japanese assistant Hatta, and they were looking for a cure for the horrible sexual disease syphilis. And they called their magic bullet Salvarsan 606 because it was the 606th time they tested it. It was incredibly effective, but also almost too powerful, and actually killed a lot of healthy bacteria. So the side effects were quite severe. So this was developed further by Gerard Domack, and he discovered something called Prontazil, which was much more effective and had much less side effects. And after a few years, scientists discovered that the key ingredient, which actually came from coal, was something called, wait for it, sulfonamide, which cured lots of other diseases like meningitis and scarlet fever. Also going to look at antibiotics. The most famous example is penicillin, which effectively destroys bacteria or reduces its growth, as you can see from that petri dish. Over time, more powerful molds were discovered, and scientists can now make antibiotics rather than having to grow them. The problem with antibiotics is that doctors have been overprescribing, and there's superbacteria these days that are resistant or becoming increasingly resistant to antibiotics. So that's a huge concern, that we might have a bacteria that we can no longer use antibiotics to kill. Surgery, massively improved in many, many ways. So, for example, these days, keyhole surgery, tiny little incision, which really reduces the infection risk. Microsurgery, so they can do operations on a much more smaller level, so nerve, on that almost nerve blood vessel level. And the picture there looks absolutely terrifying. I'm not quite sure I'd want to be that patient, but doctors quite often these days use robots to perform the surgery, using a joystick and a camera from a computer, because ultimately it doesn't matter how good the surgeon is, we all shake our fingers. Even if you hold your hands out now, it will shake a little bit. Computers don't shake, and they won't make any tiny little mistakes that can nick a blood vessel or cause some internal bleeding. Okay, in terms of prevention of disease, this has been a huge leap forward, particularly in the UK. So after World War II, 1948, the government funded tax-funded healthcare. So whether that's doctors, ambulances, hospitals, dentists back then. But the biggest improvement really was improving the national coverage of care. So moving out of London, all these big London hospitals. So really every major area in every city or town as a hospital, and that is funded by the taxpayer. A big improvement has been the rollout of vaccinations. Traditionally, vaccinations are quite expensive, so the government has funded immunisation programs, although recently there's been some resistance to this, like for the measles, mumps and rubella that young kids have, because people don't want their kids to get injected. However, there's been a big increase in those diseases. An important area where the government has been involved is passing new laws, whether that's to do with air pollution, reducing the pollution tax, congestion charge. I'll get there eventually. The congestion charge in London, and obviously laws about dumping waste and pumping sewage into the sea, like Sidmouth, for example. They'd have literally just pumped it. The fatberg would have gone out into the sea. And just small things like health and safety at work. Builders having to wear hard hats. So the amount of injuries at work have reduced dramatically. And things you'll be very familiar with is lifestyle campaigns, advertising like Change for Life, what we would know as public health campaigns. So the big one for this week is about penicillin. I think this is pretty easy to understand. So in 1928, Alexander Fleming came back to his lab from holiday, discovered that the bacteria on his petri dish was being killed by penicillium mold. We're all familiar with that story. He then published his findings, but because he didn't have enough money and didn't really probably understand it clearly enough, it kind of got put on the back burner, put away somewhere. 10 years later, Australian Guy Flory and his German assistant Ernest Chain began to opened this again and began working on it and testing it on mice. And a couple of years later, they did a successful test on a human, but he died. The reason for that was there simply wasn't enough penicillin to keep him alive because it was coming from mold. Mold obviously takes weeks to grow, and really they just didn't have enough. In fact, they had to take his urine and reproduce the penicillin from the urine, but he still died. So the real game changer of this was the mass production. And like lots of things in history, things came together here. And this was World War II. So loads of American soldiers were dying, or lots of soldiers all over the place were dying. And US companies were persuaded, drug companies were persuaded to start pumping lots of money into this drug, this miracle drug, because people realised the potential of it. So by 1942, there was a mass production, which was really growing this mould quickly and enabling it to be mass produced. So by D-Day 1944, pretty much all the medics on the beach would have had penicillin ready to go. And by 1951, scientists had enabled it to develop a chemical copy, which took away all this kind of, quite laborious process of growing the mould. Right, last but not least, our case study is lung cancer. So the thing with this is obviously absolutely horrendous. Lung cancer is particularly bad cancer because it's often diagnosed quite late. The symptoms are really coughing and tiredness, which people often confuse with infections. And unfortunately, by the time it's diagnosed, the tumour is well developed. They would have to use a CT scan to identify it. So it's really two types of treatment. Surgery. So if you're lucky enough to get it identified early, they can remove the tumour, or they will use radiotherapy or chemotherapy to try and shrink the tumour. But the key thing, I think, with this is, because it's so difficult to diagnose, the key thing is about prevention. And this is something that has radically changed over the last 10, 15 years. So, for example, these days, tobacco companies can no longer advertise at all. The cost and price of cigarettes has increased dramatically. It's almost, I would say, unaffordable. So a pack of 20 is about £10, and this is predominantly tax that the government has put on. They've also made a lot of legal changes. So they've increased the sale of tobacco from 16 to 18. Because obviously that's when a lot of people dabble in drugs or new things, is when they're young, probably your age. So they made it more difficult to access that. I think one of the big game changers was in 2007, the government banned smoking in public places, pubs, restaurants. And I think these days smoking has almost become kind of a bit of a social no-no. And I hardly know anybody who smokes these days. When, back in the day, 20 years ago, I think most people smoked. There are lots and lots of different things, graphic advertisements and no branding of cigarettes. They don't sell cigarettes in Tesco's or openly sell them. So they obviously keep them behind the shutter. So lots and lots of changes with lung cancer. So that's it for all our kind of knowledge of medicine. Next week, we're looking at World War I and then moving on to the other topics. Have a go doing the question. Hand it in to me next week. Thanks a lot.